The work I'll be presenting today was the basis for my dissertation. I just finished my PhD in quantitative psychology, which is basically behavioral statistics. My co-founder is Brian Nosek. He's a social psychology professor at the University of Virginia. And in January, we were funded by the Laura and John Arnold Foundation to create this nonprofit to improve the alignment between scientific values and scientific practices. It was a little crazy starting a business and finishing the dissertation the same semester, but got through. We've done pretty well so far. We received 2 other donations, an anonymous donation and a grant from the Sloan Foundation, which you've seen on a variety of slides so far. We're at just over $6 million in funding at this point. We just moved into our offices. We have a nice office on the downtown mall of Charlottesville, Virginia. If you're ever in the area, feel free to stop by. Okay, so we do 3 things to sort of reach this goal of aligning values and practices. The first is infrastructure development. You'll hear about that today. The second is community building. We're really trying to facilitate and support the community at the intersection between open source and open science. And we're doing this through small grants, bounties, travel funding, hackathons, workshops, tutorials, conferences, and these things will be rolling out in the next few months. The other thing that we do is meta-science research. So we have a variety of science projects, one of which is the Reproducibility Project. This is right now it's just in psychology. We're taking studies from several journals of several years, and we have hundreds of researchers on this project. They will decide to replicate one of the studies, and what we're looking to do is find out what is the rate of replication in at least psychology, and then what are the covariates that are involved in that rate. Okay, so as far as the infrastructure goes, the center is basically a Python developer shop. We develop exclusively free open source code. We are hiring. If you know of anybody or you're interested, let me know. The development team so far, we have a great team of interns and full-time developers. A few of them are here. Josh Karp is here. He's talking at 5 this evening. Sam Port now has a poster upstairs. Harry Rybacki has a poster upstairs. And Lindsay Simon has a very large beard, so you'll easily recognize him. He's a passionate open source developer who's really contributing a lot to the open science framework now, taking what was this dissertation project and turning it into, well, we had hundreds and hundreds of users, but a more production-worthy environment. Okay, so the problem. The problem is not new. I won't be saying anything novel here. There's a gap between scientific values and scientific practices. Spoiler, we believe that openness is the solution. The current incentive structure in science is problematic. It's based around publications. My professional success is tied to my ability to publish. That ability gets me jobs, tenure, promotions, funding. It gets my students jobs, it gets my students funding. Departments and universities are judged by this in their rankings. And the real issue is that published is not synonymous with accurate science, and we know this. I'm more likely to get published if I propose positive rather than negative or null findings. If I present a confirmatory rather than exploratory version of my work. If I produce novel results over replications. And knowing that how to get published basically creates this bias, these methodological biases that we see in the literature, and really overall inaccuracy. So this is the only Python code that you're going to see in this talk. You can, in the spirit of reproducibility, you can fire up a console and make sure it replicates. It hasn't been ported to Python 3 yet, so be careful of that. Okay, so my professional motivations are at odds with my motivations to do good, accurate science. Okay, so Brian and I are psychologists, so this is where we do think we have a little bit to add to this dialogue. And what happens when those motivations are in conflict is that a psychological process is instantiated called motivated reasoning. So without intending to do it, I will accept findings that support my hypotheses, but really scrutinize those that don't. If I get unexpected results, I'll reconstruct the narrative, the history of the work that I've done, to reflect it as something that I predicted the whole time, rather than something that just happened. I'll downplay or ignore or forget exclusion criteria that I use, say, in my statistics. And this has nothing to do with me being untrustworthy or evil. It purely has to do with me being human. These things are natural parts of human processing. Okay, so what do we know about scientists? They don't start by being open. They focus on efficiency. We're busy people. They're often constrained by their collaborators. We work with people. Their constraints are our constraints. We want to do accurate science. We're not often sure how to, but we will use tools that make openness practical, and that's the important part. So we need to take the solution and modify it. And we believe the focus really needs to be on incentives and workflow. We need to incentivize openness in the workflow, in the scientist workflow. This is the place they derive their day-to-day success, and we can't just append openness to that process. If you tell me to go online after I get published and make my data available, I would love to, but I'll do it after the next publication. I'll do it when the next project's done. And so it will never get done. Okay, so what are we doing with the Open Science Framework? The OSF is a web application for collaborating, documenting, sharing, registering, and archiving scientific materials across the scientific life cycle. And that goes from project conceptualization to project archival. And we sort of do these things to deal with this incentivizing at the workflow level. We respect the workflow. Scientists still have to be successful in the current incentivization structure. We still have to publish until that changes. Maybe there will be changes on the horizon, and it looks like there might be, but we still have to be successful. So we need to respect the workflow. We need to be robust to different workflows. We need to integrate private and public workflows. We need to incentivize openness, and we need to support both top-down and bottom-up approaches to this incentivization. So we can't mandate openness by any means. We can work with people that can, funding bodies, societies, journals, but we have no authority to say you have to do these things. What we can do is take, look at what happened in the open source software development community, take those values and apply them, and hopefully we'll see the same success of this bottom-up approach, this bottom-up growth. Okay, so I won't be doing a live demo today, but I will quickly sort of bring you through what the OSF currently looks like and then where we're going. So we started public beta back in November. We have over 1,000 users. As of about 3 weeks ago, we had over 1,000 users. You log into the system, openscienceframework.org, and you see a list of your projects. Okay, so here's what a project looks like. Basic stuff, you have a title, you have contributors, you have timestamps. Okay, you need Wi-Fi. Okay, good. And you have some tools that come along with projects. Dashboard, wiki, statistics, files, etc. Okay, so components. This is the way we organize projects. Components can be thought of in 3 ways. They're units of the scientific process that either 1, have independent contributor lists, 2, have independent private or public policies, so authentication policies, and 3 can be thought of as encapsulated in some way that they have some independence of their sister components, so that if you would take a component, it would have value on its own. And that's how I at least explain how people might think about structuring their projects. You don't have to, but that's how I envision it. Okay, so what else do? We track everything. So in that misremembering or reconstructing the narrative, if we have the narrative there, it makes it very hard for us to do that. At that point, we have to intentionally say that, we did something different than we did. And that's usually enough for most scientists. Most scientists don't want to be unethical. They want to do the right thing. We just have bad memories, especially under the constraints of motivated reasoning. So we collect who did what, where they did it, what they did, when they did it. All right, so one big problem that we have to immediately confront is the sharing problem. We can easily incentivize use of the system if we can make it easy to share materials. Someone leaves the lab, they take the data with them. I need to check all my email and find out what materials generated this data, where is the data, who has it. They say they don't have it, but they do, and it's an email conversation. It's just this is a real world problem for scientists. So we want to make sharing easy. So you click add contributors, and it's shared. That's it. So if we embed this into the workflow, it makes sharing that workflow very easy. Okay, so we do basic metrics, the alt metric stuff that people are talking about, page views, unique views, and all those sorts of things. So these are other incentives to judge your reputation. Okay, so let's go into a component. A component looks just like a project. It has the same sort of structure. In fact, projects are components. They're just a certain type of component. I'll go into the files and drag and drop a file on there. When that happens, it's added to the list. It uploads. I go to the file. I see the file, and I see versions of that file. This is a simplified front end to Git. Git is working in the back end. We want to lower the barrier of entry for version control. It's an important part of the process, but it's a little bit too high for a lot of scientists. So what we want to do is sort of develop teaching materials, wizards, automated sort of workflows that take someone from this simplified interface to possibly using the command line. And we can do that simply, basically like GitHub does it. We'll authenticate via HTTP, and that's a whole project that we're working on. Walker, somewhere in the room, he started that at PyCon sprints, and he'll hopefully wrap some of that up this week. Okay, so the next thing, if you want to make things public, it's very easy. You just click the button, and it's made public. You can keep certain things private, certain things public. So you want to keep your data private because of some anonymization issues, well, you can keep it private. You don't have to make everything public. Once things are public, you can use that Git backend to your advantage. We have forking at the project level. It's actually a random shuffle button, which has been changed, but you click that fork button, and you get a clone of the project in your space. You're the only author or contributor, and there's a link back to the original. Now you see your number go up, and that link is basically a citation, but a very functional type of citation. We think this is an important metric for the future of reputation evaluation. Who's using my work? Are they expanding it? This is very functional. And it's basic version control. Okay, so I upload maybe my measures. I want to freeze the state of the project before I start collecting my data. Okay, so this is registration. I go to the registration page. I see a bunch of registration templates. These will be user contributed eventually. They can go on and use a small scripting tool to do these. I select a template, and that basically is a survey. So they can define a dynamic survey with conditionals and loops and whatnot. And this is just metadata that gets attached to the registration. So have I looked at the data? Has data collection begun? No. Continue. And I get a frozen copy of the project. It has a unique URL that can be embedded in a publication. So I can say, if you want to see the exact materials that I used to collect this data, and materials evolve. Immediately as I start collecting data, I've started another project that uses those materials. So it's very hard to keep track of those things sometimes. So this is basically like tagging and version control. But you get this unique URL of the exact state of the project that can't be changed. So you get the metadata. We're working on making this API based. We're working on creating these components as services. So that data component could be connect to, say, Harvard Dataverse or S3 or DuraCloud. And an analytics component might connect to an IPython notebook in the cloud. And those things, as long as they talk to us via API, can talk to each other. You can pass that data to the IPython notebook via some metadata, the message passing, the handshakes, and now you can analyze that data set that you have defined in the system. We want to work with a lot of groups. My entire month really has been setting up these collaborations. We have a huge to-do list, a lot of fun things to do. If you're interested in any of this stuff, especially the API stuff, this is where we really think there's value in connecting these really great services in this community. I'd be happy to talk. I'd love to talk to you about it. Again, Josh's talk's at 5. Posters are upstairs. We're holding a open science BOF at 7 p.m. We're going to be at the sprints. Let me know if you have any questions. Jeff at centerforoPenScience.org. Thank you. It was added to the board upstairs.
Ah.
Oh, which talk?
5 p.m.
Oh, that's on the schedule in the symposium, the the mini symposium.
Ah.
Josh Karp.
Great topic, fascinating stuff. So I come from SciPy network, so we do something similar. One of the things that we've run into is not enough time to look at that governance systems for instance, that we're using. That is the problem that we have
That is something that we're addressing. We have other groups that have developed systems to do some of these things, and we're working with them via these API collaborations. One of them is going to be basically developing a front end on top of the OSF. We have no monetization needs, so people can just develop these front ends. They're going to be doing one of these and adding that provenance governance tracking into that. And we have version control and those sorts of things, but there's a layer above that that some people need, that those services, we're happy to work with those people. They're experts in their domain, and we don't want to recreate that. We want to work with them. Yep. No, you can use the site entirely privately, and that's fine. But when you're ready, there is that make public button always sitting there, waiting to be clicked. And if you're convinced by openness, then you can click it. Yep.
So at the end of the passage, you mentioned the idea of looking to an IPython notebook, which is really appealing. But I have an IPython notebook that's open on a server. It wouldn't be your server for long. Like, you can't just let people run arbitrary commands on the server.
So, okay, I forgot to repeat the questions, but IPython notebook, security on the server, can't let people run commands on it. This is where you would, in that, defining that component, you would add your authentication, a private key, for example, to be able to authenticate that just for your contributors. It wouldn't just be a free-for-all. I mean, you probably shouldn't have it be a free-for-all. Yep.
It's just metadata that you download and run on your local machine.
It could be that way too, yep, yep. Any other questions? Thank you.